Hi, welcome back to my friend Permu's patio. It's a little breezy here and cool. It's a nice summer afternoon. We live by the coast, so it's really a great time to have big thoughts and enjoy doing some math. This is the fourth part of the series on simplifying square roots, where we'll get to the big payoff. And I hope you've watched the first three parts on divisibility, whether or not the numbers 2, 3, 5, and 11 go into a number. Short division, on how to divide numbers very quickly, especially when dividing by numbers up to 10. And the most recent one we saw, prime factoring, how to turn most numbers into a product of prime numbers. Today's the last day where we'll finally get to help Permu with her problem with square roots. To do that, we have a very fundamental idea that we need to talk about first. I'd like you to take a look at these examples. The square root of 9, the square root of 4, and the square root of 25. Most of us know these at this point. The square root of 9 is 3, because 3 times 3 times itself is 9. And I'd always like to think about what are the words that are behind some of these symbols. Well, there's a question here. What number times itself is 9? That's the square root. It's really a question. And there may be many times when if you'll just ask yourself the question that goes with the math symbol, you'll figure it out right away. Whereas focusing just on the symbols to begin with can be difficult. But that's what this symbol means. What number times itself is 9? So what number times itself is 4? What is the square root of 4? 2. And what is the square root of 25? Well, what number times itself is 25? That's 5. This is early stuff, probably early in middle school. You learned these. But what I'd like you to look at is that this is exactly the same as that. Can you verify that for yourself? Is the square root of 9 the same as the square root of 3 times 3? And this is just the square root of 2 times 2. And this is just the square root of 5 times 5. So notice then, whenever I have a pair of factors inside the square root symbol, what's called the radical, and believe me, if you pull a potted plant out and it has square roots, that will be radical. Inside this radical symbol, this square root symbol, if there's a pair, it just comes out of the radical. Radical's gone. Likewise with this, and likewise with that. Most of the time, I would like my students to have their factors written like this, rather than powers. But your teacher may prefer that you write it this way. Can you see that these are all the same? That 3 squared is the same as 3 times 3 is the same as 9. And again, it's just the base number of this exponential expression. Likewise, 2 squared, likewise, 5 squared. I hope you see this. If you'd like, take a moment here, see if you can come up with a couple of other perfect squares that you can quickly do this way. Welcome back. I hope you had a second to think about some of these. Did you think about one? Well, let's try here. How about the square root of 121? Well, if I factored that, that's the square root of 11 times 11, and that's just 11. Okay? And I think you can see that if Permu only had potted plants where we had integers and no square roots, she'd be very happy because those would be very healthy plants. But I think we can clean up some of her problems too. Let's try to find this. The square root of 45. What number times itself is 45? Well, let's go looking for pairs. Are there any pairs inside 45? Let's do our prime factoring. Whoops, 45. And there are no 2's in 45 because it's not even. But 4 plus 5 is 9, and 3 goes into 9, so 3 goes into 45. So 3 times 15. This is not prime. 1 plus 5 is 6, 3 goes into 6, so 3 times 5. Now, that guy is prime, the 5 is prime. So I'm done prime factoring. So I'm going to change the way I write this to look like this. 3 times 3 times 5. And so if you'll notice, I have this the same, right? This is the square root of 3 times 3 is 3, and the square root of 3 times 3 is 3, and the radical's gone for that. So I'm going to bring the 3, this pair of 3's, outside of the radical, and I'm going to leave the 5 inside. And that's what we call simplified. There are no further square roots, perfect squares inside this. The square root of 5 is actually an irrational number. If you remember from middle school or possibly elementary, an irrational number is a number that cannot be written as a fraction. And this number will, in fact, go on forever after the decimal point. So this is actually a perfect answer from the standpoint of math. And if I was in science, I might estimate it with a decimal. But for math, I'm going to leave it just like this because it's perfect and beautiful, just the way it is. Why don't we try the square root of 242? Well, that seems very difficult, doesn't it? Well, let's go back to our factoring. 242 ends in 2. So I'm going to divide this into that, and I don't need to know offhand what it is, although I'm sure many of you have figured it already. Let's do our short division. 2 goes into 2 one time with nothing left over. 2 goes into 4 twice with nothing left over, and 2 goes into 2 one time with nothing left over. This is an odd number, so there are no 2's. What about 3's? Well, 1 plus 2 is 3, plus 1 is 4. There are no 3's in this number. How about 5's? There are no 5's because this number does not end in 5 or 0. But 11, let's remember our rules for 11, the two end numbers add up to be the digit in the center. So there's an 11 hiding in here. And all of you who know your math tables got this 11 times 11 right away. 11 is prime. So I'm done. So let's rewrite our square root, our radical, as 2 times 11 times 11. Okay, and we'll look for pairs. There's a pair of 11's here. So the square root of 11 times 11 is 11, and I have the square root of 2 left over. So we're going to refer to this as the simplified form of this square root here. Why don't you take a moment, see if you can pick a number, don't make it too big, and try to work out the square root, see what happens. It's certainly worth practicing, and it's not too difficult to task. Thanks for coming back. Let's wrap up here with a couple of more examples, and then you can go off to practice some on your own. Let's pick a number like 60. Why don't you take a moment right now, stop the tape, and see if you can figure the square root of 60 in its simplest form. Great. Well, I'm going to prime factor 60. 2 does go into this because it's even. 2 times 30. And 2 goes into this because it's even. And 2 goes into 3 one time with 1 left. 2 goes into 10 5 times. No more 2's because it's odd. There is a 3 because 1 plus 5 is 6. So 3 times 5, 15. That's a prime number, so I'm done. Let's rewrite 2 times 2 times 3 times 5. And do you see a pair? Sure, there's a pair of 2's here. Square root of 2 times 2, remember up here, is 2. So the 2 is going to come out. And I'm not going to leave 3 times 5 here. I'm going to say the square root of 15. And that's the simplified form. Let's try one more. That may seem fairly difficult. Let's try the square root of 96. And why don't you take a moment to try this yourself and see if you can write the simplified form of the square root of 96. Okay, let's prime factor 96. This is an even number, so I have 2's. And I hope you see that this way of doing prime factoring really works your multiplication skills. It's a great little tool. 2 goes into 8 4 times with 1 left, and 2 goes into 16 8 times. Okay, this is an even number again, so I'm going to go for 2. 2 goes into 4 twice. 2 goes into 8 4 times. Even number again, so 2 once again. 2 goes into 12, into 2 one time. 2 goes into 4 twice. Even again. And still not prime here yet, and even again. So 2 times 3. Let's rewrite our radical, and it's going to be a long this time, the square root of 96. 2 times 2 times 2 times 2 times 2, 2, 3, 4, 5, times 3. Okay, how many pairs do I have this time? 2 pairs of 2's. So a 2 is going to come out, and a 2 is going to come out. What do you think will happen there? Well, let's look at this whole thing. 2 times 2 is 4, times 2 is 8, times 2 is 16. The square root of 16 is 4. So when these guys come out, they multiply. And it'll be 2 times 2. So 4 times the square root of 2 times 3, 6. And that's really it for simplifying square roots. I think it's fun. It's kind of a puzzle. And with those basic tools about divisibility, short division, and prime factoring, you can break these down very quickly and come to the simplified result you want. Thanks for coming. I hope you'll go look at the series on permutations and combinations, and for others that we're doing.